All right, I guess we'll start. Well, first of all, I'd like to thank everybody for coming out and welcome you here to the offices here at NEO for Full Stack Manitoba 2022. Oh, you can't hear? No? Oh, okay. Well, I'm not going to do this the entire time, so I'll have to wait, you know what? I think we can get this going. There we go. Yeah, so I was saying, thank you very much for coming out. This is great. We haven't had a meetup for 2 years. I think the last one was February of 2020, and we had no clue what was on the horizon. And so this is great that we can all get together again. So yeah, if you're here to learn about GraphQL. Maybe you already know about it. But by the time we finish here, you'll have a really good understanding of it. Today we are, let's see if this works. No. Yeah, okay. Oh, there we go. Okay. So presenting today is myself, Craig Tataryn. I'm an employee at NEO. Been here about 7 months, and previous to that I was a contractor extraordinaire. So I joined actually the same day as Jordan Brauer, our co-presenter. We develop lots of GraphQL resolvers using MongoDB, TypeScript. And if you don't know what NEO is, we're basically building a bank on TypeScript. So go figure. There's no COBOL here. We don't have a mainframe computer or nothing like that. We have AWS. So it's a brave new world for sure. So yeah, I'd like to thank NEO for sponsoring the refreshments and the space. And I know that Full Stack has a whole slew of other sponsors that have sponsored us over the previous years. So hopefully we'll get their support for the one that we're going to be doing maybe next month, and maybe somebody here would like to do a presentation, which would be amazing. So if that is the case, please come see me after the event, and we'll get that scheduled in. I just wanted to take a quick poll. So how many people are familiar with REST APIs? Okay, excellent. How about GraphQL? Has anybody written any GraphQL? Okay, that's a pretty good number. That's excellent. And for those who haven't written a GraphQL, how many are interested in maybe doing that as a next project or revamping a project? Perfect. If there's anybody left over, maybe this isn't the right talk, right? So just gotta, I gotta get that out of the way. What we're gonna cover today is we're gonna cover a traditional REST API. It's gonna be based on the Star Wars API, if you guys are familiar with that. May the 4th be with you, by the way. I forgot to say that. We're going to go over some of the things that you can do with REST APIs, because out of the box, REST APIs are almost a choose your own adventure. So we're going to go over declarative API definition using schemas and getting some documentation for your REST APIs. Requesting only what's needed from an API. Sometimes an API just throws the whole kitchen sink back at you, and you, as a front-end developer or as a consumer of that API, you don't want it all. And then this problem that we call the N+1 problem, where we may request some data from an API, and then we have to request a bunch of other data for subcomponents, one after the other. So an array of things. And that becomes a problem because you have so many API requests, it might actually overwhelm your server, which isn't great when you're scaling. And then maybe some ideas of how you could, scale a REST API using microservices architecture. Okay, so like I said, we're going to be using the Star Wars API, and you can go to the swapi.dev if you want to check that out. They have a nice set of documentation, and you can actually query the API right there on the site. And then I'm going to kind of actually show you how you can do that with your own REST APIs. But this REST API will expose Star Wars characters, their films, vehicles, and the planets that are in the Star Wars universe. Okay, so here's an example of what you might get from the Star Wars API. So you do a GET request against this endpoint. You pass in an ID for they call it people. I don't know. There's a lot of like non-people in Star Wars, so I don't know why they chose that, but it's basically any character in Star Wars. If you give it an ID, it's going to pass you back something like this. And you have to kind of ask yourself, as maybe a front-end developer, how do you know what it's going to pass back, right? Like, I mean, you've probably been in this boat like I am, where I'm exploring an API and I literally just make requests and see what kind of stuff I get back, and then I code something to consume that. It's not the best, right? It's not the best experience, especially if you don't have like a sandbox API to work with, right? So luckily in REST APIs, you can implement these things called JSON schemas. So just as a database schema would be for your, this is for your REST API. So you can kind of have a schema input or schema for your input types, so the things that you're maybe posting into the server, and then your return types, what you're getting back from the server. So what you do is you set up this this schema, and in this schema, for instance, a starship, we're going to say here are all the required properties, right? Then here, down here, I don't know if you can all see it, but here are the actual properties, and they would extend down the whole screen. But the films, okay, it's of a type array. Okay, it's of a type array, but what type of item are in the array, right? Like, so you can actually drill into the Star Wars API itself does not drill into that detail, but using JSON schema, you can actually say this is an array, yes, and it's an array of films. And then the film type is defined somewhere else that you're going to look up. This is really good because it would play well with something like generating documentation for your website, right? So maybe you're exposing an API to your users and you want to give them some documentation for it. Instead of you having to like learn WordPress and try and keep that all up to date, you just write it into your schema, and then something in your build would generate those HTML files that get pushed out to S3 and shown to your peoples, right? Okay, so you can define these JSON schemas. Great. How do you actually make them do something? I don't know, that might be a little bit small, but I'll just kind of take you through this. Let's pretend that we're using an Express API. So you've coded this in JavaScript or TypeScript, and you're using Express.js to serve your API. So you're going to define this root here, and it's going to be a get, and it's going to be the people /ID. And you want to enforce the fact that, and this actually isn't a good example because it shouldn't be a get, it should be a post. But what we're doing is we're defining some kind of schema for the input object that we expect people to pass into our API. And then what we do is, like, if you've ever used Express, it's there's probably a middleware for anything. You define a middleware that you associate with your route. So right here, we're associating the validator middleware, and we're saying, hey, for any body that's coming into our route, we're going to try and enforce this schema. So if our users decide to pass us garbage, there's going to be some intelligent response back through the API automatically. Yes? I don't think I can because it's just a slide. Yeah, I know. Yeah, we could turn those off for sure. I don't know what actually controls that. I don't know. Maybe John knows. Oh, like this one here, you can't turn on? This one here? That stays on. Okay, sorry about that. Yeah, so the general gist here is that you define a schema, and this might be just in a schema file somewhere that gets imported, and then you want to enforce it, right? You don't want to you want to clutter your own controller code, your own handler code with a bunch of like, did they pass me this? Did they pass me that? Is it of the right format? Should it be a string? Should it be an int? You can let this middleware do it all based on the schema. So that's great. So input and output objects we have covered. Okay, there's this other thing called Open API. So you can create an Open API document that has JSON schema inside it. And what Open API does is like everything. You define your entire API, like what endpoints you have at your API. Okay, it takes a certain object. What type is that? Okay, there will be a reference to a JSON schema object. Validation, okay, is it going to be an int? Okay, should it be between a certain value or else we'll just reject? It can do a lot of stuff, plus all the documentation for your API. So you can have all these documentation type properties. And at the end of the day, some tool can take all this information and enforce your schema. So make sure that people are passing you the right things, make sure you're passing back the right stuff. But also you can set it up to be part of your build, so you're kind of creating this API documentation and you're publishing it out somewhere. And there's some really fancy build time tools that will digest an Open API document and will actually not only just spit out like, here's what the API is, here's what all the objects and types are, but also, do you want to test it? We'll give you a little sandbox environment and will allow you to, right through this web page, will allow you to try it out. If you've ever used like something like the YouTube API or any kind of Google API, if you go to their docs, you're actually able to try out their APIs right on the website, which is super, super valuable, right? Try before you buy kind of thing. Yeah, so any thoughts? Well, this is really confusing actually to somebody, especially that hasn't been around for a while, because Swagger and Open API are almost used interchangeably. And that's because Swagger, it started out as Swagger, and then people were like, we really got to standardize this thing. So we'll make a committee and we'll do Open API. And so Swagger and Open API are pretty much the same, but then I think Open API started like literally redefining what JSON schema is. And then somebody, I think at some point said, whoa, we already got JSON schema. Can't we just like make this part of Open API? And so it's a little bit ugly in that case because it can get pretty complicated. It's not the nicest thing to look at when you're looking at an Open API document. And this is the real problem. It's not always used. Like if I go to a client and I'm building REST APIs for them, they might not have any of this stuff in place. And then I'll come in there and go, we should really be using Open API, and they'll be like, yeah, no, we're not going to do that, or whatever, right? We tried that, but it was too complicated. So it's not enforced, and I don't think that's a good thing. And you also have to consciously keep things up to date, and there is some tooling that helps you with that. Like for instance, in TypeScript, you could put decorators around certain parts of your API, and that will feed back into the Open API document that gets generated at build time. So, okay, that's cool, but it's like, geez, that's a lot of mental gymnastics to do. The good thing is it is language agnostic. I mean, you can use Open API with Python, you can use it with TypeScript, JavaScript, PHP, Laravel, that kind of thing. It's got it's not its own little language, so it's just YAML or JSON, and there's probably like an XML version of it and that kind of thing, and it's an open specification, so there's no hidden bits. So right on. Okay, that's good. And okay, so that was very abrupt. Okay, so that's Open API. This is another thing with REST APIs. Okay, I'm a front-end developer, and I want to, I'm a front-end developer. Go away. Okay, mouse wants to stay. Okay, and sorry guys. OCD. Got to get rid of this guy up the corner. There we go. Okay. Okay. You're a front-end developer or you're a consumer of an API, and there's an API to get people, but you don't care about films. You don't care about species, you don't care about vehicles, you don't care about starships. Maybe those are huge. Maybe there's a lot of data and you're not displaying that on the page. You don't want it. What can you do? Well, if the API developer didn't write any kind of special code in there to let you filter out that stuff, nothing. You have to request and just disregard it, right? So there's some solutions, and I've probably done all of these over my career. We can make special little parameters on our endpoints that go, okay, I want the people with the films. I want the people with the starships, et cetera, or the reverse. Or sorry, not the reverse, or with specific fields. And this can get really hairy. And if you've ever used, again, a Google API, they attempted to do this all. And I bet they really wish they had GraphQL at the time, because this would have been super simple. But what you got to do is you got to say, okay, well, I want the people, but I want only with these fields. Oh, there's an array here. Well, I do want the name from the starship, so I got to create this funky syntax for saying, like, oh, I want the name from the starships, and you know, oh, what if that's null? Like, it's just a nightmare to code all this stuff. And then, of course, the opposite of this one, like, I don't want to specify every single thing that I want. I just want to have all the people without these fields, like without starships, without films, etc. So problems with that. Well, if you do this the wrong way, your controller code that's servicing all these APIs, they're going to get bloated with all this, like, if they used with films and it's true, then I want to query that from the database and I want to make sure that's in the payload that goes back. You're really gross. So you might say, well, I'll just use middleware. Well, okay, but it might not save you from querying the database, because middleware is, I'm going to inspect something on the way in and maybe do something, and I'm going to inspect something on the way out. So you might have this nice clean controller that queries every single thing from the database, and then your exit middleware will filter out the stuff you don't want to send back to the client. You still spent all the time, you know, querying the database, so that's not really great. And you might have cooked up, you know, some special stuff, special sauce in your REST API, but not everybody has. Okay, so this is what it feels like. This is what it feels like making a REST API. Finally, I get to write my controller code. Awesome. Scaling. So how do you scale your API, right? So you have this API that's servicing all your endpoints. You can load balance the whole API. So you could just spin up several instances of the entire API, and then when a request comes in for people, some load balancer is going to intelligently pick which one isn't under load to service that. And then you get a nice spread across that. But what if it's the Starships API that is the one that's getting hit all the time? Why do I have to, like, replicate the entire kitchen sink just because that one's being hit really hard? Like, why can't I drill down and load balance only that one thing, right? Well, that's a monolith, right, API for you. It's you got to redesign that. So you could split endpoints into microservices where every single endpoint is or some combination of endpoints are split out into microservices, and then you could easily load balance those instances. So you could just load balance the starships. That's a pretty good solution. But what about embedded data? Like when we were calling the people API, underneath in the payload we had starships. How do you load balance that? It's in the payload, right? So that's a little bit problematic. So maybe you would allow them to query all the starships underneath a person, but then in behind the scenes it's doing service-to-service calls through a load balancer to the microservice that provides starships. That can get really complicated too. You could also return URIs instead of the actual data for like things like films. And then it's up to the client to go, do I need films? If I need films, I'll go and query those things separately in separate responses. And these are all under their own endpoints, so you could, you know, those could be part of a microservice that's being auto-scaled. Okay, that's great. But that also introduces an n+1 problem. So I query the one thing that I need, and then I need these n other things, and I got to make n other requests to the server. You're eating up all the request threads. Pages loading slowly. It's not a great experience. So to sum up, We want APIs that are well-defined. So we want a well-defined API. We want both the endpoints to be well-defined so that I can query your open API schema and see what you're advertising. And I want to know what I should pass in as input and what I should expect as output. This is really tool and IDE friendly. So like I said, you could have that build time tool that spits out a nice page and lets you actually exercise the API, and that can actually create like IntelliSense for you, right? That's cool. So we want an API that actually the documentation and all this stuff reflects the true state of the API. So we don't want a developer going in and adding some new functionality and then, or changing it and not updating the documentation for it. And we definitely want a documented API so that we're not just poking around. And we want an API that's validated. If I pass you garbage, you should pass me back an error saying like, hey, that was supposed to be an int, you passed me an emoji, right? And sparse, we only want to query what we need. We don't want the whole kitchen sink. So now Jordan's going to show you how GraphQL can actually solve all those problems. But until then, we're going to set up for him. And I was thinking this would be a good time for a little 5-minute break. Grab a drink. If you have to hit the washroom, they're just behind this wall here. And yeah, we'll set up. Great. Thank you.
Hi, everyone. Don't mean to interrupt the great conversation that's going on. Just want to check first. Can everyone read the screen? You're too far back. Yeah, come to the area if you want to see. Take that as a yes. Okay, cool. So I'll start with introducing myself. So like I said, my name's Jordan, and I've been doing software for pretty much my entire life. As a hobby as a kid, you find out about Flash and ActionScript, and you start making games and stuff like that, all the way to doing it professionally for last 5 or 6 years. A couple of companies I worked at, Tipping Canoe or Pepper. Maybe some of you have heard of it if you're in Winnipeg. I was at Goobagoo as well for a little while. Hi, Remy. And after that short-lived time at Goobagoo, came here to Neo Financial to work with GraphQL, which you're here for. So yeah, you can find me on all the socials, pretty much just my name. That's pretty much it. So yeah. So we're going to start by kind of busting a few myths surrounding GraphQL. Maybe some of you have some preconceived notions about it and haven't worked with it much. And then we'll kind of go over a brief history about it, where it came from, how long it's been around, all that kind of stuff. And then we'll do a really quick crash course and maybe a little bit of a demo at the end if we've got time. And then we'll do some questions at the end, preferably. So if you see something during the talk, try to remember what slide you're on, or slide I was on, or something like that, and make note of it at the end. Is that better? Okay, cool. And then after that, we'll maybe have a little bit of a pop quiz and do some giveaways or something. So make sure you're listening. Cool. So yeah, the first thing that I always remember being talked about, or being said to me when I try to bring GraphQL into things was, it's a fad, it's not here to stay. Maybe you remember this kind of stuff with React or Backbone all the way back in the day when these new techs come out, people seem to think they're a fad and you shouldn't adopt them in companies because it'll go away and then you're stuck with all this legacy stuff. It's not a fad, I promise. The other one is that it requires a dedicated server. And it's maybe a little bit of a less of a misconception now, but in the past, I'd often see, in talking with DevOps people and everything, there's an idea that you have to have a separate server. It's kind of like a database, and it's not. It's really just, yeah, it's not a database. It can be baked into anything. And the other one that's really big and seems to stick with people pretty bad is that you're querying the database directly from the client, which is not the case. So for anyone who's a little bit worried about that, I promise you, no database stuff here. So all the front-end devs, you're not going to ruin performance with your large infinite lists and stuff. And it might be expensive to adopt and rewrite things for. We've got an API with thousands of endpoints and that kind of stuff, right? It's not actually, because you can incrementally adopt it very easily. A bit of an anecdote. When I was at Pepper, we did a huge rewrite from Vue 1 and Twig, if you know what Twig templates are in PHP. And we did Vue 2, and we decided that our API was not serviceable for what we needed to do, like data-driven, design and all that sort of stuff, right? So we decided, actually, funny enough, we did try the things that Craig had mentioned, where we decided to make our own, query system where you're excluding and including fields, and probably within a few weeks we scrapped it because we realized that the amount of tests and overhead involved, it was just too much. So we decided to take on GraphQL, and we rewrote a good portion of the app in probably about a year, and the rest of it still was using like server-side rendered templates in the REST API, and once it got to the client, it would start using GraphQL and do what it can using those APIs. The other thing is that it's not trying to replace REST or SOAP. I don't know if any of you are still using SOAP, but I hope not. But yeah, feel free to still, it's not like a one's better than the other kind of thing. It's, just what works best for you. So who made it? Probably all of you, most of you know it's Facebook. Specifically, a gentleman by the name of Lee Byron. He was part of a group. He's a co-creator, sort of the face of it, I suppose. And it started all the way back in 2012. So it's quite old now. Maybe some of you remember the Facebook Graph SDK. There's their old API, and that was sort of the precursor to this. Then they open sourced it in 2015. So again, still quite a while ago now. And since then, it's pretty much picked up a lot of steam. The Linux Foundation has sort of taken it under their wing and created a foundation specifically for it. Yeah, and an interesting thing about it too is that Lee had like some timeline in mind about the adoption timeline for the web, and we're pretty much on track for that. So he's kind of a bit of a fortune teller in that way, so it's safe to say it's not a fad. Going to have to decrease the font size a little bit. I hope everyone can still see. So, yeah, what is it, right? Like, you keep hearing about it. Primarily, it's an open source, like I just mentioned, like query language and type system. It consists of two main parts. There's the SDL, or schema definition language, and that exists on the server. And that's where, Craig was mentioning the open API stuff and the Swagger docs and, what was it, JSON schema. That's kind of analogous to that. You're defining what the API is with that. And the second part is the query language, which is pretty much identical in what it looks like, except there's a few differences. Each of them have some features that are exclusive to each other, but essentially the client uses the query language to then interact with the schema that's been defined on the server. You can see that we have these two main types, query and mutation. They're the required types that you have to implement, and beyond that you can just start doing whatever you want. There's on the query language, there's the two main forms of operations. There's the query, which is kind of your get request, and then there's a mutation, which is sort of your post request, I guess. And you can have support for arguments and everything like that. So using it is kind of actually no different than a REST API. As you can see here, if we were to make a post request to have a query, it would look like this. You can see it's just a JSON body with a query field, and it's got, let me see if I can use a laser pointer. There we go. It's got this it's got the query string as a string. And if we sent that, we'd get a data back that basically matches the shape. You can see here we're requiring the ping field, and we get a ping property back, and we get some value. And back in the schema, if you remember, it was defined as a string, so the client knows it's a string. And the same thing goes for like a GET request. So you can actually interact with the API through GETs. And this is sort of useful if you have particular queries that you want to be cached at maybe a CDN level or something that, before it even hits your servers, right? You can do that as well, and it would just yield you the same result. But you have to kind of opt into this. It's still up to you to configure your router in such a way that you're listening to post requests on your /GraphQL endpoint, or GET requests, if you will. But what about put and delete and patch or all those other methods? Which one do you use really, right? Those don't exist here. All of that's been boiled down to mutation. Again, any sort of write or like mutating operation will be put under that bucket. And query is gets, and I guess head as well. So where is it used? It's so great. Who's using it, right? Well, we are at Neo. And Netflix is also pretty big in the space. They've got lots of really good blog articles on Federation, which we'll talk about in a bit as well, and using it at scale. Pretty much all of Netflix is built on top of GraphQL APIs. I think a lot of JavaScript as well. GitHub uses it. They recently redid their API in GraphQL, and their app uses that. They still have the REST API. Again, it's not replacing anything. And there's some non-web related projects as well, like dgraph. You guys know what dgraph is? It's a database built in Go that is it uses GraphQL as its query language. Again, GraphQL is nothing but a query language. You can kind of put it wherever. So if you have crazy ideas, definitely try them out. And Shopify, Starbucks, Lyft, Airbnb, list goes on. When should you use it though, right? Well, I'd say pretty much any time you're making an API now. I would never reach for REST. If you're starting from scratch, GraphQL is right there. It's easy to go. It's consistent. Craig had mentioned that you're left on the choose your own adventure sort of thing with REST and SOAP and all these other tools. But with GraphQL, it's pretty consistent. In a previous company, when I was working with GraphQL, it was great, and I came here, and I already knew what exactly I was looking for. People were talking about resolvers, and it all makes sense to me. And even though I did it in one language at a different company, and it's in TypeScript here, the concepts are still the same because it's a reference implementation. It's implemented, as anywhere you want. And so yeah, if you're cleaning up legacy APIs as well, that's like I mentioned, you can incrementally adopt it. So if you're looking to really improve experience from front to back end, that's probably a good place to start as well. And like I mentioned, you can have maybe some crazy ideas with it. A messaging protocol would be an interesting idea. What if you used queries and mutations on not even in the front end, but as a way to transmit structured and typed data through some other kind of system? I'm pretty sure people are mixing gRPC as well with GraphQL. So why should you use it? Well, if you listen to Craig's talk, it was a little overwhelming. That maybe explains why you want to use it. But we'll go over these lists. So it's strongly and statically typed. So all of your APIs and fields and types will be validated for you. You don't have to do any of that validation code with middleware and all that kind of stuff. The types take care of that for you. No more DSLs or any sort of things based on not invented here. Like I'd mentioned, we spent about 2 weeks at one of my previous jobs making a, what we called bindle QL as a kind of joke about the hobo stick and the bag of stuff they've got with them. And we very quickly tossed that because it turned into a DSL that if we left the company or got hit by a bus, no one would understand. Like I mentioned, there's free validation, so no conditional boilerplate code in your controllers, which are called resolvers in GraphQL. And it also has an interesting side effect of facilitating really good communication across the full stack. So I don't know what you guys do in your jobs and how you structure teams. Full stack everyone, front enders only, back enders only, whatever. In my experience, it's a very interesting experience, way to solve a problem when a front ender and a back ender can come together and discuss the schema. What do they actually need? Like worry about what they need and then figure out how you'll do it later, right? Once you've got the schema, you can start using some other tools we'll talk about later that you don't even have to have the back ender implement things before the front ender can start working on code, because they've already know what things look like. And you can use factories or whatever to generate data. It's also got a really interesting first-class built-in documentation system. So you don't have to do some other layer on top of it like Swagger or OpenAPI. It's built right into the schema. So keeping it up to date with the code is quite easy. If you go into the schema and you add or remove or deprecate or change a field, the docs are right there. And chances are it's part of your code review. Someone can say, hey, I noticed you changed this field and how it works. Let's make sure to update the docs. And there's also no more overfetching. You only get to fetch what you need. You specify the fields you want. It's a query language. Like if you know SQL, you say the fields that you want from the table you're querying. And Federation is a really interesting practice to promote microservices, where you essentially are combining multiple graphs to create a giant graph that your clients then consume. So it's good at kind of compartmentalizing things. So yeah, I guess we'll kind of go over a bit of a quick crash course on what it looks like and what it is and its features. So the whole thing is based on a type system, right? It gives you scalars and enums and things you might be familiar with in type systems and other languages you've used. There aren't any sort of like generics or there isn't inheritance. It's pretty flat, and that's by design. You'll see a lot of heated discussion on lines about that. But what we're looking at here is a type. Let me just actually, there you go. So we're defining a type called character, and it has 3 fields. One of them is name, and we're saying that we want name to be a string. It has to be a string, and the little, I don't know if you can see it, but exclamation mark there at the end is saying that it's required. So GraphQL is a little bit funny in that whenever you're defining a field, by default it's nullable or not required or optional. You actually have to specify otherwise. And this can have some implications in your design and such. So it is a bit of a decision to make and have a discussion around. We can also say that we want like lists of things. There aren't arrays, they're lists. Or I think they actually call them collections. Can't remember, but it uses the square bracket syntax that you might be familiar with in a lot of languages. And not only is the type inside of the array required, but the array itself is also required. So you could kind of mix and match how you want things to be, exposed and validated. So scalars are sort of the bread and butter. Every field has to have a type in GraphQL, and they don't really give you a whole lot off the bat. So you only have 5 fields, or 5 scalars, sorry. There's int for integer, floats, strings, booleans, and ID, which ID is sort of, it's a number or a string, and you can think maybe you're using Mongo or something that doesn't use auto-incrementing IDs, or maybe you've decided to use UUIDs in your Postgres database or something. That's what ID can be used for. Yeah, and most other types you have to actually create yourself. And this is where things get really fun with GraphQL. So if you're to make your own scalar, sorry, I have to make the screen smaller again. It might look something like this. So in the schema, we have to use the ability or the keyword scalar, and we give it a name. So instead of type something and some body, we give it a name of just date. It's very simple. By default, this does nothing. You can use it and no errors will happen, but also no validation happens. So we have to give it some kind of way to know how to handle values. In this particular example, it's kind of a pseudocode PHP, but in lots of, GraphQL has been implemented in lots of languages. So in this case, if we wanted to implement this date scalar, we essentially have to know how to serialize it, we have to know how to parse it, and we have to know how to turn the value from the node that's coming from the query and turn that into an actual date value for the code, so that when it arrives in your application layer, you can work with that value correctly and use date functions and all that stuff. Otherwise, we essentially need to turn it into a string, because once it gets to JSON, there's no date. Sorry, and you'd throw errors and stuff like that in here if things weren't correct. So there's also enums. They're kind of like what you'd expect. They're a little bit different in that you don't have the capability to easily assign like a value to each enum. The enum's value is the value. So if you have, let's say, in your code in your database, if New Hope exists as all lowercase, like snake case with an underscore, you have to do some kind of transformation to return the Pascal case version of it with capitalized letters. But for the most part, these all just serialize to strings, and the client will know what values they get back from that. There's also interfaces. So basically, interfaces are exactly as they sound. You define, just like a type, right? You give it a name. Instead of using the type keyword, you use interface, and you give it the fields that you want. And any type that you create that you want to implement this should do that. And it has to now add an ID field. And if you don't, it won't even be able to use the schema that's generated. It'll say there's errors and you're missing stuff and whatever. Sorry. So yeah, interfaces are helpful. You'll often see them used in a pattern like this, where we want to know safely that certain things have an ID field. Maybe we want to use that ID field in the code somehow, but we can use that interface here to make sure that those types have that field. There's also unions, and this is sort of an interesting way to combine like multiple types. So in this example, we want to create a search system with Elasticsearch or something. We can create a union of all the things that we want to be able to search, right? Like imagine you're on GitHub and you're searching, you get more than just repositories back. Maybe you get users, you get organizations, that kind of thing, right? So we have to give what types for a union, what types belong to that union. And when we query it, we have to use this funky syntax, which are called fragments, and we won't get into that really because it's kind of a, I guess, advanced portion of it, but just know that you can reuse snippets of your queries and stuff like that. In this case, we're saying we want to select these fields on humans, these fields on droids, and these fields on a starship. And you could imagine that owner is actually a human as well. So we can give it some query string for Skywalker, and we'll get all the family members in the Skywalker family. We'll get droids they maybe own, and perhaps we'll also get starships that they own as well, and who specifically owns them, Darth Vader or that sort of stuff, right? So inputs are also a thing, which seems kind of weird, but we can't use types as an input. So you might find yourself sometimes duplicating a type in some way, but just changing the type of type to input. And in this case, maybe your fields will diverge a bit, but in most cases they'll be pretty identical. And it just allows us to define essentially a structured piece. Instead of having it all be flat and scalars and have a million parameters, you can essentially just create an input for that. And if we were to use it like so, we've got this mutation that's going to essentially, let's say, create a review on Rotten Tomatoes, and they give it some stars and a comment, and this would be the input that you actually give from your JavaScript code or wherever, and that would satisfy the customer review and episode variables here as well. So inputs are useful. And that first class documentation I was talking about, so there's a funny syntax. There's kind of two comments that you can do in a schema. There's the hash or pound symbol, And there's also 3 quotes, sort of for block comments. And if you do this, you can actually do like full-on markdown in here. And when you generate your docs, it's gives you the code snippets, and it gives you links and formatting. You can do headers and bolding and italics, all that fun stuff. So you can get really creative in here. And this is all part of the schema. It lives with the code, essentially. So, yeah, how do we wire that all up to code, right? I mean, that seems like a lot. I think I briefly mentioned it. There's this concept in GraphQL called resolvers. A lot of you that are familiar with REST might be, you might think of controllers. Like this is mapping a route to some code and some data ultimately. In GraphQL, it actually sits below the controller. So you would have a controller for your GraphQL endpoint that knows how to listen to the post request or the get request, like I mentioned. Probably also options. You'll see that a lot. There's done for like pre-flight cores, request type stuff. And these resolvers, rather than representing a resource entirely, they kind of actually represent a field. So if you had a query and you defined a user field for top-level query, a resolver would exist for that user field that knows how to turn that into the user type, given some inputs. So typically, they look like this. In pretty much every language implementation of GraphQL, they receive these 4 positional arguments of the parent, or sometimes called the root, which is the node or the field above you that was just resolved. So if you're in a user type, and it has a comments type that lists all of the comments that that user has made on some, I don't know, tweet or something, that comments resolver, its parent or root value would actually be the resolved user, and any other data that you attached on it, public or otherwise, to help resolve data for those comments. And you can pull the user ID and do your search in the comments resolver that way. Args is exactly as it sounds. This would be the input to your mutation or even query, and you would get a map, and this map is like it's pre-validated for you in some sense. So if you define a type as required in your schema, you don't have to do a check in your resolver for if args user ID doesn't exist, then throw some error. You can safely assume that it exists because you've defined it as such, and GraphQL wouldn't even be executing at all. So it takes care of a whole class of bugs and boilerplate. Context is some shared information between all resolvers. So usually you'll see maybe an instance of the request on there. You can look at the headers. You might see a shared database connection on there so that all resolvers can use the same database. Maybe an instance of the currently authenticated user, that sort of stuff. You can get really crazy with it. And info is like a set of metadata about the query that's happening. So you get like some information about where you are in the graph from top down to your current field, and a whole bunch of other stuff that I won't really get into, but these are sort of the 4 core arguments that a resolver has. It might depend on the language that you're in, but for the most part, this is the spec. So I guess we'll do a bit of a demo. Wish me luck. Oops. Okay, so I've just started a very small GraphQL server. It is on the Star Wars API still. So let's start with queries, I guess. Can you guys see? Okay, let me just zoom this in. How about now? Yeah? Okay, good. This is pretty much the same thing that I had in the slide. We've got a field here, and you can see some autocomplete already happening. This query is going to do exactly as what we saw in the demo. So if we just execute it right now, you'll see that we get a 200, and we have data and the field that we requested and its value. So here we're just playing ping pong with ourselves. It gets even better because we can actually explore the graph. So in most tools, you'll have some way of doing this. Instead of using Swagger or OpenAPI, again, like all these things that you have to build, this is baked into the language. So right from the top, like I had mentioned, there's those two required types, query and mutation. If we look at the query type, we can see all the fields that we're allowed to query. In this case, we only have one. It has some docs that tells us what it does, kind of. And we can even look at what its type is. Strings built in, but it still has its own docs as well. And this, yeah, you can do this for mutations as well, and we'll get to that. So that's sort of, just making a query. Again, it's just a REST request. Let me see. Let's move on to mutations next. So let's say you wanted to actually mutate some data or do something fun with some arguments. In this case, we have a mutation, and we're going to call it add. We only want to add 2 numbers. And we're going to use the sum mutation field that's given to us, and we're going to pass it some arguments. And it's a list of numbers. And if we run that, we should get 4. If I can show you the... I don't know why that's so small. I'm sorry. There we go. So you can see here there's some query variables. We're giving it right and left to satisfy this. And we give it 2 and 2. We know that they're integers. And I'm pretty sure if I change that to a string, it'll even tell me here expect to type int, right? So it knows about your graph. And if we run that, we get 4. Even more, let's kind of maybe demonstrate the free validation I was talking about, right? So let's say somehow you get a bad value in here. And if you run that, you can see that our response has a list of errors. I hope you can see that at the bottom. I'm terribly sorry for if it's small. But we get a message that tells us that int can't be represented by a non-integer value. Our code hasn't executed yet. GraphQL does this for free. There's no code I've written to do this. It's pretty great if you ask me. And you can even add all this metadata about it if you really want, which you would turn off in production so you're not leaking stack traces and all that kind of stuff. So that's great. Let's maybe talk about introspection a little bit. So this is kind of more on the documentation aspect I was talking about. We have a few interesting fields that GraphQL implementations will expose to us, and this is how we get that documentation. So let's just start from scratch here. So in whatever editor you choose to go in, you'll usually get this kind of autocomplete. And if you're a front-end developer, you get to go grocery shopping and build the query that you want for the feature you've been tasked with. This is a pretty great experience. And these funny fields that have the underscores before them, these are the baked-in fields to GraphQL. So we have the schema, the type name, and the type. And we can start actually exploring different things. Like we want to maybe look at what types are available, what the query looks like, what the mutation type looks like, maybe what subscriptions are available. We won't talk about subscriptions. But it's a real-time feature of GraphQL. Directives as well. This is another advanced feature we won't really talk about, but I highly recommend looking into them later if you are interested in this. But if we start, if we query that, we're going to get exactly what we asked for, and the type name of the schema is underscore underscore schema. And maybe we want to look at all the types available to us. And we only want to see their name. And we can see, we get a list of types, and these are all the types defined in the schema, right? Boolean, float, ID, those are those baked-in scalar types I was telling you about. So we haven't defined anything yet in the API. There's no Star Wars stuff. Where is that? We'll get to that. Okay. So, yeah, we've just started the server with some schema defined. So there's kind of two ways you can go about GraphQL, right? There's the first way, which is you'll often see this online, and it sort of does a disservice to the tool or the language, in my opinion, but you'll see a code-first approach a lot, where people are defining resolvers and their schema, actually, sorry, in JavaScript. And it works and has its own pros and cons, but the widely accepted best practice is a schema-first approach, where you're writing the SDL usually manually, but there are some tools around that as well. And you can see this looks, I hope you can see, it looks pretty close to what we were seeing in the slides, right? So we've got that sum mutation, and we've got that ping pong query, and we've got these other fields here as well. That we've defined, right? We've got some server info, it looks like, some films and characters, and we've defined a bunch of types, and we've given them documentation and all that kind of stuff. And if you have an editor, you can even have like autocomplete and jump to and go to definition with this. So it's a fully featured language. So like all kinds of stuff in here. So if we like, sorry. If we wanted to see, if we wanted to query the films that were available to us, right? Like we get all that autocomplete still, right? These are all the fields we've defined, and we can make use of the graph nature of GraphQL and start querying things beneath the films, and we get autocomplete for that as well. If we were to just query this, you can see we get, oh no, we get, not only do we get the films, but we also get the characters that are in that film, and only their name. So none of that other junk. We don't have to specify anything to exclude or whatever. The query itself is the with fields that you'd see in an open API. And the same thing goes for the reverse. So you can actually have as many top levels as you want. You don't have to just expose characters through films. Again, it's a graph. So everything can be connected to everything as far as you want it to be. Yeah, so that's defining the schema and having that work. The next part we'll kind of talk about is the N+1 problem, because GraphQL isn't devoid of that. If we check out another branch here. Okay, so there is this concept called DataLoader that helps with N+1, and in GraphQL you could imagine that if you had a list of movies, or I guess characters, or users, and each of those users has comments that they've written, if you query let's say you query comments, okay, and each you want to know the author of that comment. If you got a list of 20 comments, you're going to then probably be making 20 queries for those 20 users. And that's not so great, because chances are a lot of those users are the same user. So you're hitting the network a lot and hurting the database. Let me just pull that up. So in this case, to demonstrate that, we've got characters and the world that they were born on, their home world. So if we query that, we can see we get that, right? We get Luke Skywalker, he's from Tatooine, and C-3PO and R2-D2. But underneath the hood, this made, I think I have it backwards. I do. See, this is why you don't do live demos, right? And I've chosen to write this example in Go, but you could do TypeScript, PHP, Rust. There's implementations in pretty much your favorite language. We'll start with the example of doing DataLoader first, I guess. We just queried 49 planets for 82 characters, as opposed to querying 89 planets 89 times. You can see we get Tatooine, Naboo. We get all these duplicates. Like, we just wasted all that time. So DataLoader kind of lets us say it's essentially a buffer of IDs that each resolver will contribute an ID to, and at some point someone's going to actually make a query to the database, and the loader is going to receive a list of keys, and it knows how to map those keys to the values. And each node in the graph and the response will then say, yeah, I just want that one, and it'll tie that to it. And if it's already been loaded, great. You just saved a bunch of time and resources. So yeah, that's the data loader and how you might prevent performance issues. The other glaringly obvious thing, maybe, is that it seems to be, I did not set up an example for this, but you could imagine that if we had something in here for the home world that now can list the characters that are born there, you could then query home world again under each character, and you create this, it's a graph, it's infinite. So you can solve this through lots of tools that are provided for GraphQL, one of them being like depth limiting. So you can say you can't query past 6 levels deep. And there might be other performance things that you can do, but we won't really get into that. So yeah, that is the demo side of things. Let me just pull up the slides again. Cool. So we talked about N+1. Here's kind of the what a data loader might look like in a really juvenile example. You have a list of keys, and this would be what each resolver contributed to what it wants. And you'd have some load function that would know how to take an ID, and you would basically turn this into a map of the ID to the actual thing that came back from the database. Yeah, that's how DataLoader works. It's a pattern I believe Facebook came up with, and it's pretty useful even outside of GraphQL. So the other thing that's kind of interesting is performance-wise is like on the client, you'll end up having like a bunch of components, right? And they make a bunch of requests, and it's like now you've got like 100 requests to your server, and that's sort of the same thing in a way as N+1. Like, how do you make sure that you're not assaulting the server, right? I think there we go. Well, there's a feature called batched queries, and essentially you can send a query as many queries, essentially, and each of them has that same structure that we saw earlier on, where you're just a JSON or a JSON object with a query field and maybe some variables that go along with it, and then you just get one nice GraphQL request as opposed to this mess. Some other really nice features of GraphQL are code gen. So all those types that we have in the schema, we can actually just generate types for TypeScript from, or whatever language you're in. And that's the part I was talking about, where the front-end developer and the back-end developer can come together. They can talk about the schema, hash out how they want things done, or how to look. Then the front-end developer can go along, generate their types from the schema, and the code that they're writing is none the wiser, because at the end of the day, a lot of us probably spend a lot of time in the editor as opposed to, and using auto-completion, right, as opposed to actually running it as much as we can, at least. And Yeah, documentation and the autocomplete as well. So all that documentation, you could create your own documentation page off of the introspection, or you could use a tool like Apollo Studio, or even just Insomnia or Postman and browse the documentation that way. But there's lots of ways to do it. Another thing that's kind of commonly brought up with GraphQL is authentication and authorization. It's up to you. You ought to do it yourself. Bring your own beer, right? Bring your own solution. It's another kind of contentious topic in the community, or at least it was at one point. But it sits on its own layer, right? So if you have the protocol you're using, you want to guard whatever your system is first before it actually gets to GraphQL. That could be like a JWT or a cookie or however you really want to do it. It's actually no different than a regular REST API would be, because again, kind of GraphQL is sort of just a REST API with 2 fields, or a few to define in the JSON. And yeah, below that's your app. And the same thing or same principle applies for pagination and query constraints, whether it's like greater than or equals to, or all those sorts of things you might see in other query languages where you can compare values. All of that's left up for you to design using the type system that they give you to best suit your app. Maybe you need a complicated edge node connection system. Maybe you don't at all. Maybe you don't even need pagination, so it's not there. It's there for you to decide how to implement for yourself. Error handling is also kind of an interesting one. So, HTTP errors are not GraphQL errors. If you get a 404, for example, it's not anything to do with your API. It's because they ask for a route that doesn't exist. If a model doesn't exist or something in your code, then you probably don't want that type to be required, because what happens if someone requests a user by an ID that doesn't exist? You should probably return null, and if you don't, you're going to get an error, and that's not good. Additionally, the graph will try to resolve as much as it can, as long as you're not doing anything weird in the code. But you can get data and errors back together, and through that you can formulate an experience, something maybe you've seen using Google products, where you can still use the app, but you receive a little toast message in the bottom that says, "Oh no, something went wrong," but you can still do everything fine. Chances are an error happened and data was returned, and you're able to, give the users best of an experience as they possibly can. Microservices, federation. So this is something we do pretty heavily at Neo, using GraphQL. Like I said, mentioned earlier, it's good at facilitating this sort of approach. One and the most common way, and maybe the simplest way to start out with GraphQL, is using a monolith where you've got one giant schema, and you do it all by hand, and it's just one file with many thousands of lines. I've done that. It's perfectly serviceable, but it does get kind of hairy, because eventually someone's going to say, "Hey, we should maybe split this up into a user schema and a post schema," or whatever your domains are. And that's where schema stitching comes into place, where you sort of are taking a bunch of schema files and attaching them together. And it's no different than having them all in one. It just is an abstraction when you're actually coding and working with it. But with microservices and federation, you use what's called a gateway. And this is something that all requests are made to this single point, still a / GraphQL or query endpoint, whatever you want to call it. And its job is to essentially, distribute where those queries go to based on the query that's given, because each service will contribute a piece of the graph to the overall graph, and you can load balance that as well, and each individual service below that. So, if we want to look at an example of that. Oh, by the way, this is that code gen I was talking about. I hope you can see. I've been saying that a lot. So we have this, there's a tool here. It's a JavaScript tool. And we got a schema, and it generates these types for us that are then usable in your code, right? You've got a role enum that now your front end doesn't have to actually code and keep up to date with API changes. Every time you go to build your code, you get the new version. because the schema is the source of truth for front and back end. Moving on. So load balancing a API might look like this in GraphQL, right? Where maybe you've just got a monolith or like a single entry point, right? This is what you do normally. But if you were to like load balance that, it'd be pretty similar to how you would in a regular REST API, and that you're just taking the same thing and copying it a bunch of times and saying, go to the person who's least busy, which is totally acceptable. But if you do microservices and federation, again, I hope you can see. There we go. You get something that looks a little bit like this. So you have a query that you write and you send it to the gateway, and the gateway goes, all right, I know how to break this up and send each piece off to its own service. You have a character service, maybe a film service, maybe a planet service, maybe a vehicle service, maybe a droid service. You can break it up whichever way you want. And each one defines its own schema, right? And these are the parts that each of them contribute to the overall schema here on the right. Sorry. That is then what you would traditionally kind of handwrite all at once in one giant schema. So we do this a lot at Neo. It's a really interesting approach because you're able to sort of only focus on the service that you need and not worry about other graphs in the same way that you would have to worry about other services using REST, because what you need, you kind of can pretend that it's already there and you're in a monolith. It is a really good developer experience. And each of these services is then load balanced on its own and has its own resources depending on how hot it is in usage. So yeah, that's federation and microservices. I won't really dive too much into it. It's kind of its own topic, but we do this a lot. Netflix does it a lot. There's lots of good articles out there on it. Read it. Read about them if you're interested. So I've talked your ear off about what's so great about GraphQL, but there's a few hairy parts as well. So the learning curve can be a little bit nasty. If you're not used to working with a graph data structure, it's hard to wrap your head around, especially when you've been doing REST or SOAP or something for so long, because it's a completely different paradigm. So if you're adopting it into a team where nobody knows anything about it, someone's really got to spearhead it and be the one to champion the learning it and teaching that, because it's completely different than REST. Performance can be a little bit weird because you're spending this time parsing the schema and you're spending the time parsing the queries that are coming through, and it's turned into an abstract syntax tree that it's its own programming language, right? So there's a lot of stuff going on behind the scenes before it actually gets to your code. And that can be a little bit much at times, especially if you're using languages like JavaScript or PHP, not compiled, right? There's a bit of a hit there. And there's ways around that. You can do caching and stuff like that with the process schema and whatever, but it can also be a little bit messy and unorganized. So like I mentioned, microservices, as great as they are, it also is a little bit confusing at times because maybe you're not sure where that type's actually coming from. And maybe you have to do a bit of investigation and make sure that you're not duplicating a type or recreating a type. But there's tools to explore the graph that help you with that process, rather than having to do Control F on a Swagger doc page and hope you search for the right word. But there's also a familiarity. So public APIs, maybe you won't find a lot of GraphQL public APIs. Because not everybody knows it. It's not as ubiquitous as REST is and stuff like that. For example, GitHub still has their REST API available. They didn't replace it with a GraphQL one or deprecate it. Yeah, so to kind of recap and maybe mention some key things. So there's no select star. You can't just query everything. It's pretty explicit, and this is something I've been asked about before, is well, what if I just want everything? Well, then you got to say everything. You can make a fragment that's called everything on that particular type and share that and use that everywhere. But again, you're sort of implementing your own pattern and solution for these things using GraphQL. Resolvers are functions, right? So if you can think of resolvers as controllers, they're nothing fancy. It's not like a class that extends something. They're basically just a function that has the same positional arguments, and each of them are representing a field in the graph, whether that's a scalar type or a complex object. It knows how to resolve that data. The schema should represent your business domain, so not the application, right? We might be tempted to use technical jargon in there and say, like, call a type an object, or use the words like response, request, and all these things in there, but you can kind of actually do away with that and use the schema to model your business logic, and even have product people in on the discussion about these kinds of things, because the syntax is so lean that, again, everyone can sit down and really hammer out what a type is and what that means to the business before actually implementing any code. And Federation as well, it's lets you, compose a final graph from many subgraphs that talk to each other that way. So thanks. You can find the code for the talk. I put it on GitHub. I'm sure, I don't know if there's a place for this after, but I'm sure it'll get linked somewhere. Slides are also in there, and you can find me on social media as well. So I don't know if there's any questions.
We'll put a link to this in the full stack Manitoba Slack, so if you're not on that yet, just let me know and we'll tell you how to get onto that. But yeah, great job, Jordan.
Thanks.
Thank you very much. So yeah, we'll open up questions. We've been just fire hosing stuff at you guys, so your turn now. If anybody has a question.
Wait, I think we have a mic for you. We've got technology.
Thank you. So I know you said that it was a bit contested, the auth with GraphQL, but like, what would you suggest for, say, like an RBAC kind of solution? Or just, do you have any recommendations for a specific technology when it comes to auth with GraphQL?
Yeah, so my personal take on it is, if you're in the web, stick with a cookie and handle that on your controller beforehand, and maybe you can mix that with like CSRF and get some feedback here, and make sure that you've got essentially at that point you have to actually make a GET request to the server before you make the POST request for your queries and everything, and that's pretty much the most common way I've seen it done, and done it myself as well when bringing GraphQL into a project, because you've got to kind of use what's there when you're adopting it in. If you're starting from scratch, though, I'd probably just stick with a JWT and use that instead. Yeah.
Can I give a follow-up to that?
Yeah.
I meant more so in the sense of like filtering out like parts of a query as to what that specific JWT, for example, has access to of the entire graph. Because that's a bit of a unique problem I faced when dealing with these kind of GraphQL queries as opposed to REST APIs, where everything's very explicit.
Right. So we have a pattern for this at Neo, but I won't talk your off about that. The simple answer is that each resolver, you can, because it's a function, you can kind of strap whatever mechanisms you want to it, right? Yeah. So you could make a class that has a bunch of things in it, and it ultimately creates a function for the graph. And in this class, maybe you have some property that defines like a list of roles that or permissions that the person has to have so that they can make a request. And if they don't satisfy that, an error will occur from that resolver, and you'll probably get null back on that field, which, depending on how you've made your schema, will cause an error there. So you just got to be careful with how you do that. But yeah, typically right in the resolver, you can just make a check for your permissions and handle it that way.
Thank you.
Yeah.
Yeah, actually, another way we're trying to tackle that too, we're looking into, is you can write decorators for parts of your graph, so like @ annotations.
Yeah.
Oh, yeah.
So you can imagine you have like your graph, you have a field, and you're like, well, I only want people that have a certain permission or a certain role. You'd be like @ check role, and then put the role in there right on your graph, and then your front end people know exactly like, hey, I need to have this role in order to.
That's good. Thank you.
Right, yeah, like directives, that's, I think that's the name of the feature. Yeah, and I've done that as well. You can create a directive called private, and it will error, let's say you have an email field on the user, make a private directive, put your logic in there for how you want it to behave, and anyone who requests that field who's not authenticated as that user, it'll error or return null. Yeah.
Okay, so you said that it's not a database? Okay, so which database systems work well with it?
Yeah, anything you want actually. So you could use a flat file that has JSON in it. It's pretty agnostic to what you're using, right? Yeah, anything you want. So Postgres, Mongo, it can talk to multiple things. Yeah, anything. In fact, you could have REST APIs behind your resolvers. So you could mask an entire nasty legacy API with GraphQL, and maybe the performance sucks, but at least it gets the the developer experience better, and then people can spend time fixing that experience, right, or that performance.
Okay.
Anyone else?
I have a question about best practices of versioning actual schema. So how do you handle that if you need to make a change in a schema and have customers informed, whatever?
Yeah, so there's GraphQL doesn't version, okay? So it sounds weird, right? But there's actually this concept just called deprecating forward, where if you need something to be redone, like a version 2 or whatever, you're going to use the same schema. You don't have to. You could just create a second GraphQL endpoint called GraphQL v2, and all your new stuff's there. But the kind of best practice surrounding is to use what's called a directive, right? And this is built. There's a few of them built into the language, but you can say like use people instead, right? And if I save that, I hope this works. If not, but essentially, yeah, that's going to tell whoever's using this now that oh well, I didn't do it right. Oh well. You would do something like that, right, where essentially you mark it as deprecated, and then you're going to come along and add the new thing. And after you've made sure that nobody's using that old thing anymore, the deprecated thing, you delete it. And there's, again, tools that would help you know that. So if you were in a production environment and in Teams, you'd probably use something like Apollo Studio, where it lets you explore all kinds of things about the graph, not just the schema. And you can see what services you have and all that sort of stuff. And when was the last time a field was queried? 2 months ago was the last time it was called. Okay, probably no one's using it anymore. Let's remove it. That would be sort of the best way to version and move forward your schema.
Thank you.
Yeah. Anyone else?
I think you might have covered this a little bit in the hairy parts of GraphQL, but I'm curious maybe if you expand a little more. Let's say 20 years from now, there's two new hotshots up here talking about, a new piece of tech that's going to replace GraphQL.
Yeah.
What are they going to complain the most about GraphQL when it comes to that?
I got to be honest, it's hard to complain about it. Yeah, like there isn't. I don't know, Craig. Do you? I can't really complain about GraphQL.
No, I don't know. Just maybe the initial learning curve, because it is very different, right? And like one thing that new people to GraphQL don't really grasp is that every single field in that graph can be its own resolver in a completely different service somewhere. Even though it's under this one type, that other field can be serviced by some other thing, and they all layer. And like so, when there's a field under another thing, you get passed in that other thing so that you can use it to query whatever you need to query. So I think it's just learning curve, but like 20 years from now, I hope the learning curve, people are just using it. So
Yeah, definitely the learning curve, I guess. Yeah, it probably took, I don't know about you, but maybe when I first learned it, like 2 weeks to really understand it at like a level that I felt comfortable. Yeah.
That's pretty fast.
YouTube helps a lot. Anyone else? Cool. Okay. Well, like I mentioned, we have some pop quiz stuff. So swag bags are here. I don't know how we want to do this, but I guess hands and see, pick randomly. All right. So first question: GraphQL allows you to query your database from the browser. True or false? Yeah, give him swag bag. Hands. First hand I see, I'm gonna pick. Okay, so the next one. REST is a terrible way to create an API, true or false? False is correct, yeah. I think I saw a pink jacket first. Yeah, so again, we're not saying replace it, right? Just, it's a different tool.
Just to note, yeah, I don't know, Jessica who works there, she put this all together. So there's a coffee mug in here and a bunch of stickers and some notepads and stuff like that.
Yeah, yeah. The bags are great. I honestly use them for grocery shopping all the time. What is the N+1 problem?
You query one thing, and then it comes back with an array of data, and you have to make another query for each one of those data. And then it just answers.
Yeah, swag bag.
On the front row is just killing it here.
I know. Come on, someone in the back. Hands. Yeah, t-shirt gun. We should have got that. Apollo and GraphQL are the same thing. Who said false? Okay, gentleman in the back with the Dragon Ball shirt. That kind of wins you the swag bag already. So that's it. Thank you.